Here we have a SAT math question. Okay, so here we have a rectangle with dimensions 8 and 11. Okay, let's go with the information. Squares of side length 2 are removed from the corners of an 8 by 11 piece of paper shown above by cutting along the dashed lines. So the sides of the paper are then folded up to create a rectangular box with an open top. How many cubes of side length 1 are needed to completely fill this box? Okay, here we are going to remove, according to the question, squares of side length 2 are removed from the corners along the dash line. So this part is removed, and this part is removed, and this part is removed, and this part is removed. So here this each part is a square of side length 2. So this is 2, this is 2, and here we have 2, here we have 2, here we have 2, 2, 2. Already we know that the length of this side of the rectangle is 8, but here, so 2 units are removed over here and here. So we have only 4 units left. So because 2 plus 2 is 4, when I remove 4 from this 8, I'll have just 4 units left. And here, on this side of this rectangle, so the total length is 11 units, but 2 units are removed over here, 2 units removed over here. So in the middle, we'll have, so 2 plus 2, 4. When I subtract 4 from 11, it will be just 7 units. Okay, then, okay, now let me draw the base of the box. Just a moment. Okay, now after removing the squares on the corners, what we are going to do is actually the length of this part is now just 7 because the total length is 11. So the 4 units have been removed from 11, and the length of this part is just 4 because the total length is 8. So 2 plus 2, 4 units removed from this 8. So now clearly the base of the box is 20. I mean the area of the base of the box is 7 times 4 is 28 square units. And one more thing is, so this part after removing the squares on each corner, so the part I'm shading in green color are folded. So then this part will become the side of the wall. So since this length is 2, so the height of the wall of the box will be 2 units. Okay, now let me draw the box over here. Okay, so when I fold the green color shaded region over here, so I'll be getting a box like this. So here when this, already we know that the width of this part is 2. So when this portion is folded, then it will become the height of the box. So the height of the box is 2. Already we know that the dimensions of the base is 7 and 4. So what's the volume of the box? So the volume, to get the volume of the box, we have to multiply the base area, that is 4 times 7 times height. So 4 times 7 is 28, 28 times 2 is 56 cubic units. Okay, so now we got the volume of the box created using the paper shown. Okay, so the question is asking us to find out how many cubes of side length 1 are needed to completely fill this box. Okay, let's consider the cubes of side length 1. Okay, here we have a cube of side length 1. Side length 1 means 1, 1, 1. So what is the volume of this cube? Its volume is going to be, so the base area is 1 times 1, the height is 1. So I get 1 cubic unit. So the volume of this cube is cube is 1 cubic unit. So actually in the given box we have volume 56 cubic units. So how many such cubes can be filled? It's very simple. 56, because the volume of each cube is 1 cubic unit. So here total volume 56 cubic units. So you'll be able to fill 56 cubes into this box. The answer for this question is 56.